Hello, pre-calc students doing hyperbolas today. So hyperbola is a set of all points such that the absolute value of the difference of the distance from the two foci is constant. So we have the center, we have then a distance of A to the vertex. That means the distance of 2A, that would be the transverse axis. 2A, that's the transverse axis. Transverse axis. Then B, that's half of the conjugate axis. So 2B, if you had a length of 2B, which is that length right there, that would be the length of the 2B, that would be the conjugate axis. And transverse axis is the axis that aligns with the vertices, the two vertexes. And the conjugate axis is the line perpendicular to the transverse axis. We have our center HK, and then we have the distance C. C is the focal length. And the focal length is the distance from the center to the focus. From these focus, we draw parabola-like shapes going out from the vertex. And this is a horizontal hyperbola because the parabola-like shapes go off horizontally. And these parabola-like shapes approach the asymptotes, which have the slope of the vertical axis over the horizontal axis, in this case, the conjugate axis. Half the conjugate axis over half the transverse axis. So in this case, this would be B over A. So the asymptotes go through your rectangle. So the Pythagorean relationship is A squared plus B squared equals C squared, which is different from the ellipse, which is A squared minus B squared equals C squared. Moving on, looking at our orientations, the horizontal orientation, the x term is positive. The vertical orientation, the y term is positive. All right. The asymptotes, the conjugate axis, the transverse axis, the foci, the center. One thing is the covertices would just be vertices and the covertices. The vertices would be for the horizontal h plus or minus a, comma k, and the covertices would be h, comma k plus or minus b. And then the opposite for vertical orientation. Let's draw this out. Let's look at h here. H is actually going to be -1 because that's x minus h. This would be x minus -1 to be x plus 1. K would be -2. If 9 is equal to a squared, because a squared is always the positive term, then 3 is equal to a. Square root of a squared is a, square root of 9 is 3. If 16 is equal to b squared, then 4 is equal to b because square root of 16 is 4. Square root of b squared is b. Now c, our Pythagorean relation, is c squared is equal to a squared plus b squared. So c is equal to the square root of a squared plus b squared. So that's equal to the square root of 16 plus 9. 16 plus 9, that is 25. So that's the square root of 25. And the square root of 25 is 5. So c is equal to 5. Now our orientation, our larger denominator, that matters for ellipse, but doesn't matter for hyperbola. Whatever term is positive determines orientation. So because the x term is positive, the orientation is horizontal. Our center is HK, so that's -1, switch the sign, -2, switch the sign, -1, -2. Our vertices, now that we know that A is 9 and that we are horizontal, it's going to be our center coordinates, -1, because we are horizontal. The vertices lie on the horizontal transverse axis. So that's going to be plus or minus a. So -1 plus or minus 9, comma, -2. The co-vertices, while not included, that would be -1, and b is 4, so that would be -1, comma, -2, plus or minus 4. Our foci are going to be -1, oh, and I'm so sorry. A squared is 9, a is 3, so it's -1 plus or minus 3. So erase that, that's -1 plus or minus 3, because a is 3, not 9, a squared is 9. Our foci is going to be -1 plus or minus square root of 25, that's going to be 5, plus or minus 5, comma, and then the y value of the center stays the same. Now our asymptotes with a horizontal, we're going to have b over a. So our asymptote is going to be plus or minus b over a, so that's going to be 4/3 x minus h, so it's going to be x plus 1 plus k, which is going to be -2. So that's x minus h plus k. So we're just following from the previous slide before. Well, let's do another example. Here, our h value is what we're adding subtracting for the x term, and so we're not adding anything from the x term. So our h value is 0, and our k value is actually +2. Act y minus +2, y minus 2. A, well, a squared is 25, and b squared is 12. So a is equal to 5, and b is equal to the square root of 12. The square root of 12 can be simplified as 4 times 3, so that's equivalent to 4 is, the square root of 4 is 2, so that can be simplified as 2 root 3. Now c is going to be equal to the square root of a squared plus b squared. So the square root of a squared plus b squared, that's going to be the square root of 25 plus 12. And 25 plus 12, that's going to be 35, 37. So that's the square root of 37, and we just keep it like that. Okay? So let's look at the orientation. Now our orientation, we have a vertical transverse axis because the y term is positive and not the x term. We have our center. The x coordinate of the center is 0. The y coordinate of the center is +2. Our vertices, well, a is equal to 5, and the vertices function vertically. They are on our vertical axis. So the vertices are going to be 0, 2, plus or minus 5. So that would be 0, 7, and 0, -3. Our foci, c is equal to the square root of 37. 25 plus 12 is 37. So the foci are going to be at 0, 2, plus or minus the square root of 37. And our asymptotes. Now instead of b over a, it's going to be a over b. So the asymptotes are going to be at plus minus, not b over a, but a over b, 5 over the square root of 12. of x minus 0 squared, so just keep that in x, plus x minus h, and h is 0, plus k, so that's going to be plus 2. So those are asymptotes. And once again, this can be done efficiently by drawing our ellipse. So if you really want to work at drawing the hyperbola, you have your center. So here our center is 0, 2. Our x value is 0, or y value is 2. So imagine that point is 0, 2. Then our a value is 5. That's vertical. So we move 5 up. So that value is 5. This value is 5. Our b value is the square root of 12. That's 2 root 3. That's 2 times 1.7. That's approximately 3.14. So it's a little bit more than 3. We have 3 horizontally. You draw the box. So you draw a rectangle from all your axes, and you draw asymptotes that go through the corners of the rectangle, but go through the center. And then you draw parabola-like shapes that approach the asymptotes from your vertices. And then lastly, you draw your foci, which are root 37 away from the center, each vertically. All right, so that was an experiment. Let's move on to the next one. Okay, this is a trick where what we have to do is simplify, and we have to simplify by factoring out the coefficients for the x terms, first we have to combine the x and y terms, get the constant on the other side, factor out the coefficient for the x terms and the coefficients for the y terms, and then complete the square and finish up the problem. So let's group the x's and the y's. Let's do blue here. 25x squared plus 100x minus 16y squared plus 96y equals 444. Now we factor out the 25. 25 factored out of x squared plus 25. So actually that's x squared plus 4x. So that's x squared plus 4x. And then we have our complete the square term for the x's. And then we subtract, we factor out a negative 16. And what's left is y squared, and 16 divided by 96. So 96 divided by 16 is 6. So that's y squared. And because we factored out a negative 16, that's y squared plus 6y. And then we have our complete square term. And that's going to be equal to 444. Our coefficient for this complete square term is 25, so that's going to be plus 25 times our complete square term for the x, plus 16 times our complete square term for the y. So let's complete the square. For this x term, we take that coefficient 4, we divide 4 by 2, that's 2, and then we square 2, and that's 4. So our complete square term here is 4. For our y term, we take our coefficient here, which is 6. 6 divided by 2 is 3. And then 3 squared is 9. So our complete square term here is 9. This will factor into 25 times x plus 2 squared minus 16 times y plus 3 squared and that's going to be equal to 444 plus, and this is multiplied by negative 16, so that's actually going to be a subtraction sign. So my fault, because that 9 is multiplied by negative 16, it has to be multiplied by negative 16 here. That's going to be 444, and let's bring out the calculator here. On the right hand side, I can do 444 plus 25 times 4, that's 100, minus 16 times 9. So that's going to be 400. And then all hyperbola standard forms are equal to 1, so I divide each side by 400. 25 divided by 400, well, 25 times 4 is 100, so 25 times 16 is 400. So this will simplify to x plus 2 squared over 16. X plus 2 squared over 16 minus, and if 25 times 16 is 400, 16 times 25 is 400, minus y plus 3 squared over 25 is equal to 1. And because our x term is positive, this orientation is a horizontal orientation. All right, the center would be at -2, -3. Our vertices, well, let's see. A squared is equal to 16, so A is equal to 4. Take the square root of each side. Because we are horizontal, our vertices would be at -2 plus or minus 4, comma, -3. To do some more calculations, if A squared is equal to 16, A is equal to 4. B squared is equal to 25, and B is equal to 5. C is equal to the square root of A squared plus B squared. So that means C is equal to the square root of 25 plus 16. The square root of 25 plus 16 is going to be equal to 35, 41. So C is equal to the square root of 41. And so our foci will be at -2 plus or minus the square root of 41. So that's a little more than 6, less than 7, minus -3. Our asymptotes, A is 4, B is 5. We have a horizontal orientation. So our asymptotes are plus minus, not A over B, but B over A. Vertical over horizontal, rise over run. So 5/4 x minus h, so that's going to be x plus 2 plus k. K is negative 3, so it's going to be minus 3. Those are our asymptotes. All right, this problem, group the x's and the y's again. 9x squared minus 36x minus y squared plus 10y plus 2 is equal to 0. So here, all we have to do is factor out the 9 and get the 2 over to the other side. So now I have 9 times x squared plus 9 times what is 36? 9 times 4 is 36. Plus 4x plus r, complete the square term, minus y squared plus 10y plus r, complete the square term, would be equal to negative 2 plus 9 times a complete the square term for the x, and because we are technically multiplying this by negative 1 minus our complete the square term for the y. So let's complete the square term for the x's. 4 divided by 2 is 2. 2 squared is 4. Complete the square for the y's. 10 divided by 2 is 5. 5 squared is 25. 2 squared is 4, so we have a 4 in this box. 5 squared is 25, we have a 25 in this box. 4 in this box, 25 in this box. So now I have 9 times factored out x plus 2 squared minus y, and that's going to be 5, so it's going to be minus y plus 5 squared is equal to negative 2 plus 9 times 4, so that's negative 2 plus 36. So it's going to be 34 minus 25. It's going to be 9. And then at this point, I divide each side by 9. And I will get x plus 2 squared. 9 divided by 9 is 1 over 1 minus y plus 5 squared over 9 is equal to 1. And once again, it's the pot. We have a horizontal orientation because the x term is positive. So our orientation is horizontal. So we have a horizontal transverse axis. So our orientation is horizontal. Our center is negative 2, negative 5. Negative 2, negative 5. All right, your vertices are at negative 2, negative 5, plus or minus a. How do we find a? Well, a squared is equal to 1, so a is equal to 1. So that's going to be 5 plus or minus 1. Our foci, we need to find b. B squared equals 9. B is equal to 3. C is equal to the square root of a squared plus b squared. So that's going to be equal to the square root of 9 plus 1. So C is equal to the square root of 10. So our foci, and oh, this is a horizontal orientation, so we have a mistake because we have a horizontal orientation. And a is equal to 1. Our vertices will be at negative 2 plus or minus 1 comma negative 5. And our foci will be at negative 2 plus or minus the square root of 10 comma negative 5. And our asymptotes will be horizontal orientation b over a. 3 over 1 plus minus of x minus h, x plus 2 plus k minus 5. Switch the sign for the term inside the parentheses. Don't for the term that's not. The x term is inside the parentheses. The y term is not. All right, vertices at 3, -6, and 3, -3, 2. So -3, -6, -3, 2. Foci at -3, -7, 3, -3. So let's look at right here. We are moving vertically. So we have a vertice at -3, -6. We also have a vertice at -3, 2. The halfway point, this is a length of 8, right? So this distance is 8. From -6 to 2, that distance is 8. So if we move up 4, we have our center at -3, -2. +4 to go up, +4 to go down. That's our center. And we have foci at -3, 3. So these are the foci, -3, 3, and -3, -7. All right. We know that our A value is 4, because that's the distance from the center to the vertex. So A is equal to 4. A equals 4. We also know that C is equal to 5. -2 minus 5 is 7. So C has a length of 5. C is equal to 5. So now we just need to find B. So if A is equal to 4, A squared equals 16. And if C equals 5, C squared equals 25. And if C squared equals 25, then now let's do this. Then we can know that A squared plus B squared equals C squared. That means C squared minus A squared equals B squared. So B is equal to the square root of 25 minus 16, which is equal to the square root of 9, which is equal to 3. So B is equal to 3. So actually, our covertices will be at plus or minus 3. That'll be -3 will be at 0, -2, and -6, -2. These will be the locations of the covertices. -6, -2. And here, I'm going to A is equal to 4, C is equal to 5. I'm going to not obstruct drawing this hyperbola. Here's how we draw the hyperbola. We make a box between the vertices and the covertices. So make a box with the vertices and the covertices. And this is supposed to be to scale. This is not. So I draw asymptotes through the corner of the boxes. These asymptotes go on forever. Then at the vertices, I draw parabola-like shapes that approach the asymptotes. And the focus, these foci are the foci of these parabolas, parabola-like shapes. So that's the hyperbola. So one more problem than eccentricity. Vertices at -3, 0 and -9, 0. Asymptotes at y equals 2x plus 12 and y equals -2x plus 12. So let's figure this out. The distance between the vertices is going to be 6. So if this distance is 6, from -3 to -9, that distance is 6, which means 2a is equal to 6. A is equal to 3. All right? And we also know that we have a horizontal orientation because the y stays the same and the x moves. So we have a horizontal orientation So because we have a horizontal orientation, our asymptotes are plus minus b over a times x minus h plus k. Oh, and I'm going to finish off these problems because I didn't actually write the standard form. Okay, so x minus h plus k. And if a is 3, that means that plus or minus 3, or b, over 3 times x minus h plus k matches up with plus or minus 2x plus 12, which means that b here, in order to make this 2x, that has to be 6. So b has to be equal to 6. H has to be 0, because x is not modified. And k has to be equal to 12. And if a is 3 and b is 6, that means c is equal to the square root of a squared plus b squared. So c is equal to the square root of a squared is 9 and b squared is 36 plus 36. So c is equal to the square root of 9 plus 36, yeah. And that's going to be 45, the square root of 45. Um, that c is going to be equal to the square root of 9 times 5. The square root of 9 times 5, that's going to be c is equal to square root of 9 is 3, and the square root of 5 is 3 root 5. So that's what c is equal to. And now that we have a, b, and c, we can write the equation of our hyperbola that is horizontal. It's going to be x squared, x minus 0 squared, over a squared, which is going to be 9, minus y minus 12 squared over b squared, which is going to be 36. And that's going to be equal to 1. That's the equation of this hyperbola. But that's c, so you can find out all information from this hyperbola. Lastly, we have our eccentricity. Eccentricity is c over a. It's how stretched the hyperbola is. It's between 0 and 1. And with a hyperbola, it'll always be greater than 1 because your focal length will always be longer than your vertex length. So here, let's solve this. C is equal to the square root of a squared plus b squared. C is equal to the square root. A squared is 48. B squared is 36. 48 plus 36 is going to be 70, 78. Sorry, doing some math here. That's going to be 84. So C is equal to the square root of 84. And if A is the square root of is 48, A squared is 48. A is equal to the square root of 48. And so let's see if we can simplify the square root of 84 and the square root of 48. 4. So this is going to be equal to the square root of 4 times 21. And this is going to be equal to the square root of 4 times 12, which would be 4 times 3. So this would be 48 would be 16 times 3. So this would be the square root of 16 times 3. Square root of 16 is 4, so this would be 4 root 3. And 4 times root 21, this would just be 2 root 21. So their eccentricity would be C over A. That would be 2 root 21 over 4 root 3. We get our calculator and we can do 2 root 21 divided by 4 root 3. And that's going to be 3.96, and that's our eccentricity. All right, so that's our video on hyperbolas. I guess one last thing, I forgot to write the equation here. So if b is 3, a is 4, our center is -3, -2, and we have a vertical orientation, we will have y plus 2 squared, center is 2, over a squared, which is 16, minus x plus 3 squared, center is -3, the x coordinate, over b squared, which is 9, is equal to 1. That's our hyperbola equation. All right, that's everything on our hyperbola notes.